Okay, in this video, we're going to take a look at dilations. So first, I want you to think about the word dilation and where you maybe have heard this word before. I know when I've gone to the eye doctor before, if you've been, sometimes they want to dilate your pupils, which means that they want to enlarge your pupils. And when we go out into the sun, our pupils change sizes. When we go from darkness into light, and when we go out into a really bright sun, then lots of sunlight is getting into our eyes, so our pupils get smaller and smaller so that our eyes are not damaged by the sun. And when we go into a dark place, then there's not as much light, so our pupils open up or dilate open, so that we can let in as much light as possible. So notice in this diagram here, you have this green point. And that green point, as I move this around, this is your point of dilation. Just like we had a point of rotation where we were going to turn the shape or object from, in a dilation, you have a point of dilation. And when that point changes, notice the triangles don't change sizes or shapes, they just change the location, because depending on your point of dilation, it's going to be a different location. Now, if my point of dilation is in the middle of the figure, notice what happens. The figure just got bigger, and if you look over here to the right, you see the scale factor. And the scale factor is how much it's going to enlarge or how much it's going to get smaller. So as I increase the scale factor, notice that the triangle gets bigger and bigger and bigger, and we could keep going. But notice what happens when I go to a scale factor less than 1. Okay, now my triangle got smaller. And I could have a negative scale factor even, although at this level you won't be doing that, but we could, which looks somewhat like a reflection, but we can go halves or 1/3 or whatever. All right, so we're going to take a look at an example here, and our point of dilation is going to be the origin. Okay, so we're gonna dilate from the origin, and we're going to do 2 dilations. The first one is going to be a dilation of 2. So if you are dilating from the origin, you can very simply take your coordinates and multiply by the scale factor. So I've written down the coordinates for our triangle ABC, and A is at 5, 6. So if I want to do a dilation of 2, for example, then I'm going to take my coordinates and I'm going to multiply by 2. So our new location for A would be at 10, 12, because 5 times 2 is 10 and 6 times 2 is 12. Our new location for B is going to be 8 times 2, which is 16, and 8 times 2 again, which is 16. And C is going to be at 16, 8, because 8 times 2 is 16, and 4 times 2 is 8. Now, this works when you're dilating from the origin, which most of your problems are. So let's take a look. Now let's graph these these 3 points, and we go to 10, 12. So 2, 4, 6, 8, 10, and then we go up 12. 1, 2, 4, 6, 8, 10, 12. And here's my new location for A. And now I go to B, I go to 16, 2, 4, 6, 8, 10, 12, 14, 16, and I go up 16, 2, 4, 6, 8, 10, 12, 14, 16, and here's my new location for B. Now notice my triangle's getting bigger. It should be like twice the size. Now I'm going to go to 16, 8. So I go back here to 16 and I go up 8, 2, 4, 6, 8. and there's my new location for C. So this is my new triangle. And notice that it dilated from the origin, which is back here. Which means that these, let me, boom, like that, and like that, out from that direction. Okay, now let's do our second dilation, and in this dilation, you're going to do a dilation of 1/2. Well, we know that half is the same as dividing by 2. So what you're going to do in this case is you're going to divide each coordinate by 2. If it was 1/3, you would divide by 3. If it was 1/4, you would divide by 4. So these coordinates, so I take 5, 6, and I divide each one by 2. So 5 divided by 2 is 2.5. 6 divided by 2 is 3. I divide 8 by 2, which is 4, and 8 by 2 again. Then I divide 8 by 2 and 4 by 2, and I get my new coordinates. Now, keep in mind, this is going to be smaller, and it should be somewhere between the original figure and the origin, because now we're going less than 1. If it's more than 1, it should be on the other side of the figure from the origin, like we saw in the purple figure. Okay, so we're going to go to 2.53. That's my new location for A. 4, 4, which would be here, B, and 4, 2. And sure enough, there we are, right in between the origin and our original figure. So we have these 3 figures dilating out from the origin. And this figure is greater than 2, right? So this one is on the other side of our original figure. And this figure is less than 1. Oh, I think I said greater than 2. Sorry. It's a dilation of 2, which is greater than 1, which is why it's outside. And the green figure is going to be in between the original figure and the origin because it's less than 1. Okay, now let's go to your Khan Academy assignment and do a couple examples here. So in this example, we are going to dilate this point D. Okay, so D is dilating from the origin, 0, 0. And you could write down the coordinates if you would want to. You've got -3, -2. And we want a scale factor of 2. So that means you're going to multiply each one by 2. So -3 times 2 is -6. -2 times 2 is -4. So I'm going to take my green dot here, and then I'm going to graph -6, -4. So I go -6, -4, and there's my new point. Okay, now in this example, we have point P as our point of dilation, but we're not on a coordinate plane, and so we don't have it as the point, the origin as the point of dilation, but it still is going to work in the same way. So we want to dilate D with a scale factor of 1/3. So we want it to be 1/3 of it. So what I do is I count from P to D how much it's going down and how much it goes over. So let's take a look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going down 9, and then it's going over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it goes over 12. It's kind of like the slope. But what we're going to do with those numbers is we're now going to divide those by 3. So 9 divided by 3 would be 3, and 12 divided by 3 would be 4. So that means I'm going to go from point P down 3 and over 4, and there is going to be my point of dilation of 1/3. So this should be 1/3. And I'm going to check that, and there you go. All right, I hope this was helpful. Have a great day, everybody.